we are going to present fuzzy logic. I am Priyanshi Shah. With me, Nidhi, Isha, Yashashvi are my teammates. Now I am going to start with an introduction. Fuzzy logic is a mathematical framework for dealing with uncertain, imprecise, or vague information, allowing for degrees of truth rather than binary truth value, true or false values. Commonly used in control systems, decision making, artificial intelligence, and data analysis. It is based on the concept of membership function, and the implementation is done using fuzzy rules. Here, in Boolean logic, if the question is it cold, then there are only two options, yes or no. Yes is for 1, no is for 0. But in fuzzy logic, if the question is it cold, then there might be very much, or it is zero point 0.9, little, 0.25, or very less, it is zero point 0.1. Next is white fuzzy logic. First is traditional logic. Here it relies on a binary framework where statements or propositions are either entirely true or entirely false. This crisp approach operates for precise values 0 or 1. Here, it can be, while effective for clear cut, straightforward cases, this binary approach can be limiting in situations where ambiguity or gradual changes in truth are present. Also, uh, second is fuzzy logic. On other hand, it introduces a way to handle uncertainty and expresses degree of truth. Instead of a strict 0 or 1, fuzzy logic allows for value between 0 and 1, such as zero point 0.3 or zero point 0.7, representing the extent to which a proposition is true. This value captures the inherent vagueness and complexity of the many real-world concepts where clear boundaries are often absent. For instance, rather than defining a temperature as simply hot or cold, fuzzy logic can express as it's somewhat hot is like zero point 0.7 or slightly cold, capturing subtitles or traditional logic cannot. Next is purpose and advantages. Here, it is highly effective in modeling real-world scenarios with nuisance variable. This make it valuable in fields like robotic climate control, medical diagnosis, and artificial intelligence, where rigid categorization is impractical. By allowing for degree of truth, fuzzy logic can represent complex human reasoning process, supports more adaptable decision making, and yield more flexible, context sensitive outcome in uncertain environment. Next, basic concepts. Basic concepts. First is fuzzy sets. In fuzzy sets, item can partially belong to a group, unlike in a classical set where something is either in or out. This approach is useful for describing things that aren't absolute. For example, instead of saying a person is tall or not tall, we might say they are somewhat tall with a degree of zero point 0.6. In the tall category, this let us capture the in between cases. Second is membership function. This function shows how strongly an item belongs to a fuzzy set, with values from 0, not at all, to 1 fully. It let us measure partial membership, giving flexibility in defining vague concepts. Next, I will hand over to Yashashvi.
Thank you, Priyanshi. Here we define the fuzzy logic versus the classical logic. There are the many features to define the classical logic between the difference between the fuzzy logic. First is truth value. Here the classical logic binary it gives the binary truth values true, yeah, false. And the fuzzy logic it gives a degree of truth 0 to 1. That means 0 0.1, 0 0.2, 0 0.3 up to so on. And the second feature is set. That is classical logic, it gives a crisp set. And in fuzzy logic, it gives a fuzzy set. And the third is boundaries. Classical logic, it gives a strict boundaries. And the fuzzy logic, it gives a flexible boundaries. And the last is proposition. The classical logic it gives a true or the false proposition. And the fuzzy logic, that is a partial truth. For example, zero point 0.7 truth values 0 0.8 that is the truth values and next mathematical representation of fuzzy sets. Here is the notation a that is the sets x comma membership function x belongs to capital X. Membership function x define the degree to which each element x in set x belongs to fuzzy set a. For example, membership tall x is equal to 0.8 means that the height x has an 80% membership in the tall fuzzy sets. So they are the fuzzy operation. There are the many operation in fuzzy. So first is that is a union. That is or combine two fuzzy sets by taking the maximum membership value. That means membership function A union B x is equal to member maximum value mu ax comma mu bx. And the second is intersection and it combines two fuzzy sets by taking the minimum membership value. That is a mu a intersection x is equal to min mu ax comma mu bx. And the third is complement. The degree to which an element is not a fuzzy set. Mu complement of x that is equal to 1 minus membership function x.
So our next topic is membership function. A membership function defines how each input to a fuzzy set is mapped to a degree of membership function between 0 and 1. Here are some types of membership function. First one is triangular membership function. Second one is trapezoidal membership function. Third one is Gaussian membership function. Fourth is generalized Bell membership function. Fifth is symboloid membership function. So let's talk about triangular membership function. So if a, B, C represent x coordinate of the three vertices of a membership function which is represented at mu x in a fuzzy set where A represents the lower boundary, C represents the upper boundary where membership degree is represented as 0 and B represents the center where the membership degree is 1. So the graph is represented as follows and here are some equation given for the triangular membership function. Next one is generalized Bell membership function. Here a generalized Bell membership function has three parameters A, B and C. A is responsible for its width, B is responsible for its slope and C is responsible for its center. Mathematically the equation is given as follows and the slope is represented where the slope for the generalized Bell membership function will be given as minus B upon 2A. Third one is Gaussian membership function. It is usually represented as Gaussian x tends to C comma S where C and S represents the mean and standard deviation and the equation is as given where C represents the center, S represents the width, M represents the fusification factor. For the Gaussian membership function, three membership functions are given where when C is equals to 5, S is equals to 0.5 and M equals to 2, the first gram is drawn as follow. In the same way, we have changed the value of C and S and we get the respective graphs according to the values of C, S and M. Now the next topic is fuzzy interference system which is given by Nidhi.
Thank you, Isha. Now we move on to the next topic is that is fuzzy inference system. Fuzzy inference system is basically a framework for decision making using fuzzy logic principles. In our applications that we want to build for real world, we make use of this inference system to incorporate the fuzzy logic. Here there are mainly three components. Fuzzification. This converts our crisp inputs into the fuzzy values. Next, we have inference engine. This here applies fuzzy rules to the input values, which are converted into the fuzzy form. Next, we have defuzzification. This again converts our fuzzy output back to crisp value. Applications of fuzzy logic. First is the control system. So, the machines that we have use in our daily life, for example, air conditioning, washing machines, and cameras, we use fuzzy logic to make decisions based on variable inputs in these systems. Next, medical diagnosis. We make use of fuzzy logic in medical diagnosis to diagnose diseases by handling imprecise symptoms. Next, artificial intelligence. We make use of fuzzy logic in expert systems, robotics, and machine learning. Decision making. Fuzzy logic facilitates complex decision making in business, finance, and engineering. Advantages and limitation. Advantages of fuzzy logic states that it deals with imprecision and uncertainty. It models humans' reasoning more accurately than binary logic. It is absolutely unfair to use binary logic in our daily lives. So it is very important that we make use of fuzzy logic to also incorporate the same into the applications that we build. Next is limitations, difficult to determine appropriate membership functions, and it is also computationally intensive for complex systems. Summary. Fuzzy logic offers a flexible approach to modeling real world problems with imprecise data. It provides tools for creating intelligent systems that operate under uncertainty. Applications are widespread and growing across fields like engineering, medicine, and AI. Thank you so much.